So till now we saw how you can convert regular expression to finite automata with epsilon and without epsilon. Okay. Now we will see how to convert a finite automata to a regular expression. Okay. So there are in the RE to FA we had certain rules, right? So in conversion of finite automata to regular expression also we have few steps. First step is initial state should not have an incoming edge. Okay, initial state should not have incoming edge. What do you mean by incoming edge? So it should not have any transition towards itself. So here if you see Q0, V, Q1, so it should then wait. It should not have any transition like this. Okay, it should not have any incoming edges to itself. So that time what you will do, you will create a new state. Create new state with epsilon transition. How that would look, create a new state, okay, with epsilon transition, okay, Q naught, Q, B, Q1. Okay. So now this will become your initial state. So according to the first rule, this diagram satisfies the first rule, right? So initial state do not have any incoming edges. So this is your first rule. Second one is final state should not have any outgoing edges. Should not have outgoing edges. Okay. So what do you mean by that? So, so here Q1, so A, Q2, then B. So this is an outgoing edge. So something is going out of the final state. So this is also should not be there when you are converting a finite automata to regular state. That time, what you do is you here also you create a new state with epsilon transition. Understood? Same as the previous one, but here we are doing it for the final state. So you keep the Q2 as such with AB transition and create another one state and make it as final state. This should have epsilon transition. Okay. So third rule is there should be only one final state. Only one final state. So if a automata has multiple final state, you have to convert it to one final state. How will you do that? So here you have multiple final states. This is one final state. B is another final state. So here we have two final states. What you will do is you will create one new state and add epsilon transition. So Q1, A transition, Q, Q2, B transition, Q3, you create one new state, Q4, make that as final and combine it with epsilon transition. So this satisfies rule number 3. You have only one final state. Okay? So then fourth one is eliminate eliminate one state after other. One state after another. Okay. Until you have only initial state and until you have only initial and final state. Okay. So Qi and Qs. So this should be your final step. Okay. Then whatever expression is here, whatever expression you get here, it is called as cost. So whatever cost is here, that is your regular expression. Okay. Now, if you see an example, you will understand better. Okay, example one. So this is the automata, given automata. So this is your given automata. It has A, B, C, and D transition. Okay. So now you have to check for all the conditions. One condition is that there shouldn't be any incoming state edges to the initial state. We do not have any incoming edges. This is your initial state. No, we do not have any incoming state, incoming transition edges. Okay, there are only outgoing edges. That condition is satisfied. What is the second one? There should be only one final state. But here we have three final states. So what will you do? You create another one final state and combine it with epsilon transition. So Q2, okay, P, B, Q3, Q4, B you have Q5, and combine all these with to form Q6. That is your final state, and all of them will have epsilon transition. Okay, now check if there are any outgoing edges from the final state. There are no outgoing edges, so that condition is also satisfied. Now, final condition is eliminate one by one. So first we will try to eliminate one by one. First we will try to eliminate Q3. So you know all the basic regular expressions, right? For A or B will look like this. Okay, so A star will look like, we already saw all these, okay? A. So A, B will look like this, right? So you remember all this. So first eliminate Q3. So Q3 has two edges, one incoming, one outgoing. So how does it look? It looks like AB, right? So A transition, this is B. A transition, this is B transition. So how would you write that? A dot B. So remove that state, okay, A, Q2. So you will have only, sorry, Q2, you remove Q3 state, no? Now you will have only QC state. C transition to Q4, B transition to Q5. Okay. So you are removing Q3. So that transition you can write as B dot epsilon and give a direct connection to final state QC. Okay. So this state I removed, and instead of this state I have given a direct path, and you on that part you write it as B dot epsilon. This is the cost of removing Q3. Now I will try to remove Q4, eliminate Q4. Okay, so what Q4 has two edges, one incoming and one outgoing, C and epsilon. Okay, so if you see that is in the form of A dot B, right? A transition, B transition, C transition, epsilon transition. So how will you write that? Again A dot B. Here in this case C dot epsilon. So remove Q4 and give a direct connection with C dot epsilon. So how will you write Q1 A, Q2 C dot epsilon. So D dot epsilon, D Q5 is still there, epsilon transition Q6, right? So other two transitions give a direct B dot epsilon and C dot epsilon. Now you have removed Q4. Now you should remove Q5. So same procedure. So Q5 has two edges, one incoming, one outgoing, D and epsilon. So again it looks like A dot B. You can write it as D dot epsilon and give a direct path. So remove Q5. A, Q2, direct path to Q6, D dot epsilon, then C dot epsilon, B dot epsilon. Okay. Now we will try to remove Q1. So what is the final condition? There should only be initial state and final state. Right. So now finally we need to try to remove Q2. So how will you remove Q2? So Q2 has three outgoing transitions. Right. How will you write these transitions? So how does it look? It looks like A plus B, right? A or B. So A or B, but here you have C also. So this looks like B or D or C. So first you write that, then we will try to remove Q2. Okay. So how will you write this? B or C or D? Okay, Q2. Now try to remove Q2. How will you remove? How does it look like A B transition, right? So you can write it as A dot B. So remove this Q2 state and write it as A dot B. So Q1 A, Q1 A dot B plus C plus D. This goes to Q6. Understood? No. So I have removed Q2 and written it as A dot B. So now you have only initial state and final state. So our final condition is reached. Now whatever is the cost of that particular transition is your regular expression. So here the regular expression is A dot B plus C plus D. Okay. So you will see another example where you will understand better. So Q1 self loop to C, A transition, B transition, Q2 final state, self loop to. Okay, this is the finite automata that they'll give. So what is the first condition? There shouldn't be any incoming edges to the initial state. If it is there, no incoming edges in initial state. So if it is coming, then you have to create a new state and make that as your initial state. Now the condition is satisfied. No incoming edges in the initial state. Right. Second one is there should be only one final state. Only one final state. That condition also satisfied. The question itself already has only one final state. What is the third condition? No outgoing edges in final state. You have an outgoing edge in the final state, right? So you have two outgoing edges, one here and the one here. So you have to create a new state. Create a new state and make that as final. So here it is epsilon transition. That as the final state. So Q1 in self loop to C, A, B, Q2 self loop to D, and another state with epsilon transition. That would be your final state. Now this condition is also satisfied. Now try to eliminate one state after another. Okay. First we will try to eliminate Q1. Okay. So if you see Q1, you can write it as uh, epsilon dot p Okay. Epsilon dot C any number of times into A. Okay, these are the outgoing edges and incoming edges to Q0, right? Incoming edge, the outgoing edge. So it has C, first it has epsilon, okay, then it has C, any number of times, then A. That's how it is written, no? So if you see the A dot B rule, okay, A dot B is continuous transition of AB. So here we have continuous transitions, right? So Qi goes to epsilon, then Q1, it has any number of C's, that goes to Q1, then you have A which goes to Q2. So it's a continuous transition. This can be written as C epsilon, C star, and A. So that's what. You remove Q1, okay, Q1, but we have another incoming transition B. Okay, you can reach to Q2 through this path, okay, or you can reach to Q2 by Q2 B, okay, Q2 on B goes to Q1, okay, Q1 has the self function of C, or you can go, okay, this is one path, and the other path is Qi epsilon Q1 self loop C A Q1, Q2, sorry. So this is one path and this is second path, right? So this path we covered, epsilon C and A, epsilon C and A. How will you write this one? It is B any number of C's and A, but where will you give this? If you are removing Q1, where will you put this? So it starts with Q2, ends with Q2. So this is a self loop. So how will you draw this? So Q1, Qi, epsilon. I'm removing Q1, right? Sorry, epsilon will not. I'm removing Q1. So first transition I will write here. Okay. Second transition, how will you write? Q2. No, Q2. D already you have. So this is a self loop. This transition that you removed from Q1, that is a self loop. How will you write B dot C star A? Okay. Now you still have epsilon transition to Q3. Now we remove Q1. Now we will try to remove what? Q2. First, look at Q2. How will you write this D and B into your B dot C star A? These are all same self loops, right? Or condition or union condition. So how you can write that? B dot C star A, okay. B dot C star A, okay, sorry, B plus B dot C star A. So first you correct that in the diagram, then we will eliminate Q2. So self loop B plus B dot C star A. The final state is still there with epsilon transition. Okay. So now we will try to remove Q2. So if I want to remove Q2, how will you write this? So this is our continuous transition. That is A, B, C transition. Right. So you can write it as epsilon dot C star A dot B plus B dot C star A. Okay. Plus, okay, dot epsilon. You can ignore the epsilon. Okay. Qi, you remove Q2 and write a direct transition of C star A B plus B dot C star A final state. That is okay. So now we have only initial state and final state. Whatever the cost here, that is your regular state. So RE is equal to what? C star A into B plus B dot C star A. I hope you understood. Okay, there is one more example in the notes. Please go through. Um, Let me know if you have any.